Today we're going to be talking about the area of triangles, trapezoids, and kites. So last time we talked the area of rectangles and parallelograms. So today we're going to be doing similar types of problems where we might be solving for a side length instead of just finding the area of these. First, we're going to get started with a couple review problems from 8.1. Okay, the first one, if you want to pause these at any point to try them on your own and then see how I did them, I think that would be best. Okay, but how I would do this type of problem, notice we're trying to find a side length instead of finding the area. They gave us the area. Okay, always write down the formula first. Okay, even though it's a rectangle and it may seem easy, always write down the formula. So first, I'm going to plug in what I know. I know the area is 96, so I can replace that with A. I know the base is 12, so I can plug that in for B. And then S is my height or my unknown. Okay, so that's what I'm trying to find. We're going to use a little bit of algebra. Okay, since we're multiplying here, I'm going to divide by 12 to cancel it out on this side, and I'm going to divide by 12 from my 96. Okay, so when I divide 96 divided by 12, I end up with 8 for my height. Now think about the units. The units for this is just going to be centimeters because we're talking height, not area. Review number 2. This time we're trying to find the height for this one. Okay, so we need to know what the height of our parallelogram is. Okay, again, notice that we were given the area and we were not given the height. Okay, we are also given the base in this case. Okay, so again, write down the formula. The area of a parallelogram is base times height. I'm going to plug in what I know, 455, and I know that 89 is my base, and I'm trying to find h. Okay, again, I'm going to divide by my base on both sides to cancel that out. So I'm left with just h equals, and I get a nice decimal for this one, about 5.11 centimeters for my final answer. Review number 3 is a challenge one. Okay, so try and attempt this one by yourself before I do it. Notice that I gave you an angle measure, 60. Okay, I want you to find the area of this. So I want you to find out what the area of this parallelogram is. I did not give you the height though. Okay, so we do need to find the height first before we find the area. Notice that I have a 60 and a 90, and so this one up here must be 30 degrees. This, if I'm talking about this type of triangle right here, okay, notice I have a right triangle with 30, 60, and 90 that I created with the height. Because remember, the height always has to be perpendicular to the base. Okay, so now I'm given the hypotenuse in this case. So when we go from 8 to the short side, so the hypotenuse to the short side, okay, that's going to be divided by 2. So this length right here of this triangle is going to be 4. And then I have to go to the height, which means I'm going to multiply by the square root of 3. So the height is going to end up being 4 times the square root of 3, and I'd like you to keep it as simplified as possible. Okay, so try and keep it exact by keeping that square root in there for now. Okay, next, I need to find the area. Okay, so area equals base times height. Okay, I know my base in this case is 12, and now I have a height of 4 times the square root of 3. So when I multiply these together, I want it in simplest radical form. Okay, I don't want it as a decimal. I'd like you to keep it as exact as possible. So we can just multiply the 12 and the 4 together. So we get area equals 48 times the square root of 3. And that's simplified because the square root of 3 doesn't have any perfect squares that go into it. So that's my final answer for the area for this one. For this parallelogram, the area is 48 times the square root of 3. All right, so getting into our new unit on 8.2, we're going to start with triangle conjecture. Okay, the area of a triangle is given by the formula A equals 1/2 base times height, where A is the area, B is the base, and H is the height. Okay, I know some of you know it as A equals base times height divided by 2, and that's fine. Okay, just our book and the way I like to use it is 1/2 base times height. So when you're doing algebra problems, the 1/2 might be easier to work with. It kind of depends on your algebra abilities. Trapezoid area conjecture. Okay, so for those of us who don't remember what a trapezoid looks like, remember it's a quadrilateral with one set of parallel sides. Okay, so that's one example of a trapezoid. For this area formula, we're going to have area equals 1/2. It's kind of a longer one. Okay, 1/2 base 1 plus base 2 times the height. Okay, so 1/2 base 1 plus base 2 times the height. Now, for base 1 and base 2, it doesn't matter which one base 1 and base 2 are. Okay, those are kind of interchangeable there. Again, you've maybe seen the area formula for a trapezoid. Base 1 plus base 2 times the height divided by 2. Very similar to how we can do that with the triangle. Okay, but the first one is the one kind of how the book likes to do it. Okay, so make sure you have one of those written down, and remember the height is always perpendicular to the bases. Okay. Then the kite. Okay, so remember our definition for a kite: two pairs of congruent consecutive sides. And this one's kind of a little unique, where we use the diagonals in this case. Okay, where we're going to take area equals 1/2 times diagonal 1 times diagonal 2. Okay, so that means we take the full diagonal. So we take the full diagonal 1 and we multiply it by the entire diagonal 2. Okay, again, diagonal 1 and diagonal 2 can be interchanged. Okay, it doesn't matter which one is which. All right, we're going to go through a few examples here. Right, the first couple might be a little easier than the others, but I just want to make sure everybody's on the same page here. So finding the area, always, always, always write down the area formula. So area for a triangle, 1/2 base times height. Notice here, we have an obtuse triangle. My base is 11. Okay, so kind of a common misconception here is some people like to include that part in the base. That is not the base of the triangle. That's just showing you that the height is perpendicular to that. The dotted line is just kind of an extension, so that's not the base. So just 11 is the base, and our height is 7 because that's perpendicular to the base. Okay, I like to plug in everything at once. Okay, so when I plug in 1/2 times 11 times 7, I get 38.5 inches squared. Right, for number 2 here, finding the area. Okay, we're going to use the trapezoid formula. I know that some of you might be able to kind of break it apart into a rectangle and a triangle, and that's okay. Okay, but we're going to use the trapezoid formula. So that is A equals 1/2 base 1 plus base 2 times the height. Okay, our first base, 14. Our second base is 8. So A equals 1/2, 8 plus 14. And then our height, right, it doesn't matter. This is also our height, same as this, right, because they're both perpendicular to our bases. So we have times 6 here. If we're going to plug all of that in at the same time, we end up with an area being 66 feet squared. Okay, you can always like add 8 and 14 together first, then multiply 22 times 6. Okay, and then you can divide it by 1/2 or times it by 1/2. All right, this one's kind of a fun one because we're finding the height in a trapezoid. So the algebra is very important for this one. Okay, always, always, always start by writing the formula down. Okay, that's the best thing you can do for yourself, is writing down the formula, because we have a trapezoid, and then plug in what you know. So we know A is 18, B1 we'll say is 7, B2 is 5, and H is our unknown. So now it's just using our algebra skills. Okay, I'm going to simplify and do 7 plus 5 to get 12. And then I'm going to do my multiplying. 1/2 times 12, we end up with 6. Okay, we got to get H all by itself, so I'm going to divide by 6 on both sides. So we end up with our height being 3 units. Right? Always, if you want to check it, plug 3 in for H and plug in your numbers to make sure you get 18 as your area if you're ever unsure. Okay, that's always a way you can check it. Okay, finding the area, this is a kite. Okay, I know this one's a little deceiving here, but let's just say that 12 is the entire length, and let's say 18 is the entire length here. Okay, because let's just remember that we do know in a kite, if these are consecutive congruent sides here, we would know that these two parts are congruent. Okay, but let's just say that 12 is the entire length, just for the case here, because they didn't really give us a ton of information. So A equals 1/2 times diagonal 1 times diagonal 2. So all I'm going to do is plug in 12 and 18, and I'm going to plug it into my calculator, so I end up with A being 108 inches squared. All right, so kind of what I was talking about in the last one, things that we know about a kite, if we have these two sides congruent in these two sides. Okay, we know that we have these opposite parts are congruent, but we don't know that this part and this part are congruent. Notice that one is 4 and one is 9. Okay, so when we're doing the area for this one, we have to add together first our two diagonals. So diagonal 1 is going to be 3 plus 3, which is 6. Diagonal 2 is going to be 4 plus 9, which is 13. So then I plug in 6 and 13 into my formula. Okay, so when I type those into my calculator, 1/2 times 6 times 13, I end up with an area of 39 meters squared. Right, if I went too fast through this, please go back and re-watch or pause as I was going through examples, and please check the quizzes on Google Classroom.